Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we review what was covered in week 13. So week 13 was all about an introduction to fractions, and fractions are these weird looking numbers here that have a number on top called the numerator, number on the bottom called the denominator, and they're separated by this middle line here which basically says divide. So 3 over 4 is basically 3 divided by 4. So what do these numbers actually mean? Well, the number on top tells you how many groups that you get, and the denominator says how many groups there are in total. So that probably sounds a bit confusing. Let's look at a visual representation. So let's say this circle here represents a pizza, and we're going to get 3/4 of the pizza. So because the denominator, the bottom number is 4, we're going to divide it into 4 equal groups. So if you get 3/4 of the pizza, you get this, which is 1/4 of the pizza, plus this, 2/4 of the pizza, plus this, which is 3/4 of the pizza. So see, I've divided it into 4 equal groups, 1, 2, 3, 4, and I've shaded in 3 of them. That's what 3/4 means. So fractions like this, where the numerator, number on top, is less than the number on the bottom, they are called proper fractions. So I said before, 3 over 4 means 3 divided by 4. But you see, 4 doesn't even go into 3 once. Numbers like this, proper fractions, they're less than 1. You can see here that if I get 3/4 of a pizza, that's less than a whole. A whole would be 4/4. 4/4 is 1 whole. I have less than a whole pizza. So 3/4 is actually less than 1 whole. So if I look at my number line down here, between 0 and 1 is where this fraction will lie, 3/4. Because remember, as we go to the right on the number line, numbers are getting larger. Because 3/4 is less than a whole, it will be to the left of that. So if I have 1, 2, 3, 4 divisions between 0 and 1, not including 0, I'm dividing it into quarters. A quarter would lie here on the number line, 2/4 would lie here, and 3/4 here. So 3/4 you can see is close to 1. It's much closer to 1 than it is to 0, but it's not quite a whole. And just note on the number line, we can also have negative fractions. So this one over here is also a quarter, but because it's to the left of, it's less than 0, it would be negative a quarter. All right, let's now take a look at some equivalent fractions. So we went through a formal definition of what makes 2 fractions equivalent or 2 fractions the same in class. But an easier way to think of it is that 2 fractions are equivalent if you multiply the numerators and denominators by the same number. We'll look at what that means in a second. So let's look again at our pizza. So I've shaded in, again, 3/4. 1/4, 2/4, and then 3/4 have been shaded in. But no, pizzas are normally cut into 8 slices. So if you get 3/4 of the pizza, you're actually getting 1, 2, 3, 4, 5, 6 slices. You're getting 6 out of 8 slices because I have divided the pizza into 8 and I have 6 of them. So what this means is if you get 3/4 of the pizza, you get exactly the same amount as if you get 6/8 of the pizza. And that's because 3/4 and 6/8 are equal. They are both equal to 0.75, and they would lie at the same position on the number line. So why are these 2 fractions equivalent? Well, as it says up here, it's because I've multiplied tops and bottoms by the same number. To go from 3 to 6, I need to multiply by 2. And to go from 4 to 8, I multiply by 2. Because I've done the same thing to the top and the bottom, these 2 are equivalent fractions. So it turns out for 2 over 5 and 6 over 15, I want to know, are they equivalent? Well, if I want to go from 2 to 6, I times by 3. And if I want to go from 5 to 15, I times by 3. This is now a true statement. 2 over 5 is equal to 6 over 15. If you got 2/5 of a pizza, you'd get exactly the same amount as if you got 6/15 of the pizza. These two are both equal to 0.4, both occupy the same position on the number line because I multiplied top and bottom by the same number. But if I look at these two fractions, I want to know whether they're equivalent. So to go from 7 to 21, I've multiplied the top by 3. But to go from 8 to 32, I need to multiply by 4. It turns out these two fractions are not equivalent. So we put a line through the equals, which means not equal to. This one equals 0.875. This one, on the other hand, equals about 0.66. This one's actually a lot larger than this one. But they're not equivalent because you multiplied the top and bottom by different numbers. So if you got 7/8 of the pizza, you're actually going to get way more pizza than if you get 21 over 32 of the pizza. All right, let's now use this to compare fractions. So when we say compare fractions, it has a bit of a different meaning than, say, comparing in English or RE. When we compare fractions, we're determining which fraction's larger. We have two tools, two symbols to help us with this. This symbol means greater than, this symbol means less than. Note that greater than points to the right because numbers get greater, they get larger as you go to the right on the number line. So for 3/8 and 2/8, it's really easy to compare them because they have the same denominator. They have the same bottom number. Clearly, 3/8 is more than 2/8. 3 of something is more than 2 of something. So between these, I'm going to put this symbol here. Now, if you're unsure, think of these symbols as a crocodile's mouth. The crocodile eats the larger number. So this is like crocodile's mouth, and it wants to eat 3 over 8 because it's larger than that one. So what about when you're trying to compare fractions that do not have the same denominator? Well, what you're going to need to do is use equivalent fractions. See, 20 and 2 are obviously different, but if I times the bottom of this fraction by 10, it will now have denominator 20. But I want to find an equivalent fraction to a half. I don't want to change the value of a half. So if I multiply the bottom by 10, I must also multiply the top by 10. You see, 1/2 is the same as 10 over 20. These two are equivalent fractions. So now I have two fractions with the same denominator, easy as to compare. 9 over 20 is less than 10 over 20. So again, crocodile's going to eat the larger number. This is the larger number. Crocodile eats it. Turns out 9 over 20 is less than 10 over 20. 9 over 20 is less than a half. So sometimes it gets a bit more tricky. So for 3 over 5 and 5 over 8, it's very difficult to compare which is larger. So what we need to do when we have fractions like these is we need to find the lowest common multiple of the two denominators. So if you've forgotten, we learned this earlier in the year, but if you've forgotten, the lowest common multiple of 5 and 8 is the lowest number that's divisible by 5, but also divisible by 8. Now, if you don't know what that is off the top of your head, let's write the multiples of the larger number and stop when one's a multiple of 5. So 8 is a multiple of 8. It's not a multiple of 5. Next multiple of 8. Next multiple of 8. And we keep writing the multiples of 8 until we get one that's a multiple of 5. None of these four numbers can be divided by 5, but this one can. 40 is divisible by 5, meaning 40 is a multiple of 5. So what does that actually mean? What I'm going to do is I'm going to make the denominator of each of these fractions 40. So I need to times 8 by 5 to get to 40, and so I also need to times the top by 5. To go from 5 to 80, I need to multiply by 8. So if I multiply the bottom by 8, I need to multiply the top by 8. So this is what I have. 3 times 8 is 24, 5 times 8 is 40. 5 times 5 is 25, 8 times 5 is 40. I have found an equivalent fraction of this, an equivalent fraction of this, where both of them have the same denominator, 40. Now they're really easy to compare. Clearly 25 over 40 is the larger one, so the crocodile's going to eat the larger number. Turns out 3/5 is just less than 5 over 8. This one equals 0.6, this one equals 0.625. All right, let's now look at simplifying. So when we simplify a fraction, we're actually finding an equivalent fraction, but we're finding an equivalent fraction that has the smallest possible numbers on the top and the bottom. So before we saw that 6 over 8 and 3 over 4 were the same number. If you get 6/8 of a pizza, exactly the same amount as if you get 3/4 of a pizza. So these two fractions are the same, but this one, 3 over 4, is said to be simpler because it has smaller whole numbers. So when we simplify a fraction, we're just finding one that has smaller whole numbers on the top and the bottom. So the way you simplify a fraction is you divide its numerator and denominator by the highest common factor. So I know it's tricky. We just use lowest common multiple when we want to compare fractions, and we use highest common factor when we're simplifying fractions. So just make a note, not all fractions can be simplified. All right, let's have a go at simplifying these three. So let's start with 12 over 20. So I want to find an equivalent fraction with smaller whole numbers. So I'm going to divide top and bottom by highest common factor. So what is the highest number that goes into 12 and 20? That is, of course, 4. 4 goes into 20, also goes into 12. So remember, what you do to the top, you must do to the bottom. So 12 divided by 4 actually gives me 3. 20 divided 4 is 5. Turns out 12 over 20 and 3 over 5 are equivalent. Both are equal to 0.6. Both lie at the same position on the number line, but this one's simpler because it has lower whole numbers. Okay, 36 over 63. So we need to divide top and bottom by highest common factor. What's the highest number that goes into 36 as well as 63? It's, of course, 9. So 36 divided 9 is 4, 63 divided 9 is 7. These two are equivalent, both equal the same thing, but this one's simpler because it has lower possible whole numbers. And I'm sure you'd agree this fraction's a lot easier to deal with than that fraction there. So what about this fraction here, 25 and 42? Well, that's hard. What's a number that goes into 25 and 42? So why don't we find factors of the smaller number and see which go into 42? So the factors of 25 are 1, 5, and 25. This doesn't go into 42. This doesn't go into 42. The only number that goes into both these numbers is 1. So if I divide top and bottom by 1, I won't change the fraction. 25 divided 1 is 25. 42 divided 1 is 42. This is an example of a fraction that cannot be simplified. The reason we can't simplify it is there's no number that goes into top and bottom other than 1. So we just have to leave it like it is. This is actually as simple as this fraction can get. All right, let's now use simplifying fractions to write one quantity as a fraction of another. So we're doing questions like this, where you have two quantities, you write the first quantity over the second quantity and simplify. So this is the kind of question you need to be able to do. So on our last test, our class scored on average 48 out of 60 marks. So what fraction of the marks did they attain? Well, of course, they attained 48 out of 60, or 48 over 60. That was the class average because the class did really well and you're also smart. So 48 out of 60 can be simplified. So sometimes when you're dealing with whole numbers, it's tricky to find the highest common factor. In that case, you can use any common factor. So if you don't know what the highest number is that goes into 48 and 60, let's find any number. Well, clearly, both of these numbers are divisible by 2. So I can divide each by 2. As long as I do to the top what I do to the bottom, then I will have an equivalent fraction. So 48 divided 2 is 24, and 60 divided by 2 is 30. But this fraction can be simplified because 24 and 30 have a common factor. And hopefully you realize that is 6. 6 is the highest number that goes into both 24 and 30. So 24 divides 6 is 4. 30 divides 6 is 5. Turns out highest common factor in 48 and 60 is 12. 48 divided 12 is 4. 60 divided by 12 is 5. So I didn't do it in an extra step to confuse you. I just wanted you to know if you're in a test and you just can't think of the highest common factor, just keep dividing them by any common factor until you get a fraction that can't be simplified. I can't simplify 4 over 5 because these two numbers have no common factor other than 1. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.